right, we're going to start this really easy. If Jerry has 3 quarters and 5 dimes, how much money does she have? I love the sound of money. Anyway, let's think about this. You can't say she has 8 and just add these, because every quarter is worth something. So what you'd have to do is you'd have to say, okay, I have 3 quarters plus 5 dimes, and that's my total value, or what I have, right? And you'd go, well, 3 quarters are worth 25 cents, plus 5 dimes are worth 10 cents, okay? And that equals 75 cents plus 50 cents, right? Which is $1.25. So we have $1.25. Now think about what we really did here. What we really did here was we took how much something's worth times how many we had, because this is what we really did. How much times how many. And that equals our total value. This is a formula that's really important. How much times how many. Okay? And for us, it's how much the coins were worth times how many you have. For instance, the quarter is worth 25 cents times how many I have. I have 3 of them. The dimes are worth 10 cents, and I have, how many do I have? 5 of them. So it's how much times how many. And that's any of these total value problems, whether it's the total value of money or the total weight of people in an elevator. I made that one up. That sounds pretty good. Or maybe the total weight of luggage in a plane. It's all this total value kind of stuff where something has some kind of worth or value times how many of them you have. And that gives us the total sum of all of it. So that, or the total value, sorry, the total value of all of it. So that takes us to a problem that we want to solve. We have nickels, and we have dimes, and we have a total value, I'll put TV for total value, of $2.20. And then it says there are 8 less dimes than nickels. 8 less dimes than nickels. Okay, so to explain how this is, if you look at the next slide in your workbook after this problem, you'll see there's some FYI, which stands for your information, okay? When you have 2 unknowns, and we do, nickels and dimes, and you have a formula, which we do, how much times how many equals total value, we're going to use a chart, okay? So here's what we're going to do. Ready? How much times how many. You know what? This is going to get too long if I write it out like this. Let me just do this. All right, ready, guys? Here we go. How much times how many equals total value. We have nickels and we have dimes. Okay, how much? Well, a nickel's worth 5 cents, right? A dime is worth 10 cents. Okay, now, when we say how much times how many, in this problem, we mean how much it's worth by how many we have, how many coins we have. Okay, so here we go. It says there are 8 less dimes than nickels. 8 less dimes than nickels. So they're giving us information about 8 less dimes than nickels. They're giving us information about the dimes, but they're giving us no information about the nickels, so we're going to let the nickels be X. Okay? Whenever you have a chart, the information is going to fill out 2 columns, and the last column is going to be filled out by the formula. So we now have 8 less dimes than nickels. Okay, so we have 8 less dimes, so that's X minus 8. 8 less than those nickels. Now, we have this column. It's the only one left. We're going to squiggle or highlight. That squiggle or highlight says use the formula here, and that's what we're going to write the equation about. That's what that tells us. Use the formula here and write the equation about this. So now, how much times how many is 0.05 times X, and this is 0.10 times X minus 8. Okay? So we're going to write the formula about, or the equation about total value. You already know that you have a total value of $2.20. I haven't used that because I can't put 220 here because it means I have $2.20 in nickels. I can't put 220 here because it means I have $2.20 in dimes. So that just helps me know that this plus this is this number. So here we go. We're going to set up the equation. It's the total value in nickels, the nickels total value, plus the dimes total value equals $2.20. So here comes the equation. Ready? It's 0.05x plus 0.10 times the quantity x minus 8 equals 220. Now we have to solve that. Okay, so I'm just going to erase some of this board right over there. I'm going to keep this because I have to. I need it later. Okay, I'm going to solve this. And we got 0.05x. I need some space here to write, but 0.10 times x minus 8 equals $2.20. All right, now, this is absolutely up to you. Remember, you don't get a calculator. You might want to clear the decimals. We did some of this in, oh, I don't know, mod 4, 5, I can't remember. But to clear the decimal, we have to think about how many spaces we want to move each decimal point. We want to move this twice. We want to move this twice. We want to move this twice. That means we'd be multiplying by 100. So that's what we're going to do. But watch this because you want to be careful. Okay? And this may get a little sticky because there's not much space. But I'm going to multiply this by 100. Oh, no good. Okay, let me fix that. Okay, I'm going to multiply this by 100. I'm going to multiply this whole thing. This is one term because it's attached by multiplication. I'm going to multiply this by 100. And I'm also going to multiply this by 100. Now watch how this goes. There's 3 factors here. I multiply any 2 first. If I multiply a decimal by 100, I move the decimal point 2 places to the right, and I get 5x plus. Now look, there's 3 factors here. 1, 2, 3. This whole thing, x minus 8, is a factor. I multiply any 2 factors first, my answer by my third one. So I'm going to multiply these 2 first. If I multiply 100 times 0.10, I get 10. Times the quantity x minus 8. Notice the 100 doesn't go to both of these because I'm not distributing the 100. There's not a plus in here or a minus. It's just 3 factors, any 2 first, your answer by your third. Okay? Equals 220 because I moved the decimal over 2 places there. So this is what I have. Now I'm going to continue. 5x plus 10x minus 80 equals 220. 15x minus 80 equals 220. Ready? Add 80. This is going to come out nice. I feel it. 15x equals 300. Divide by 15. X equals 20. What does 20 represent? Well, 20 represents the number of nickels. So there is, and I'm going to erase this right here. There is 20 nickels. 20 nickels. And there's 20 minus 8, or 12 dimes. That's my answer. You know we can check this. Think about this. Oops, check. You know we can check it. Think about it. Here's the check. If I have 20 nickels, well, nickels are 5 cents. So if I have 20 nickels, that's $1. If I have 12 dimes, that's $1.20. And that is $2, where'd it go? $2.20. So there's my check. But I have 20 nickels and 12 dimes. And the reason we set this up is we have a formula and 2 unknowns. Okay, remember, again, the information is going to give you 2 columns. The last column is made from the formula, and it tells you what to write the formula about. So that's how to solve these. We're going to try more of these. Okay, let's see how we can use this to solve other problems. At a recent soccer game, 102 tickets were sold. Okay, so we sold 102 tickets. I know that. I got that. Okay. And a total of $330 was collected. So $330 was collected. Okay. And there were student tickets that cost $2 a piece. And there were non-student tickets, okay, that cost $5 a piece. Okay, how many of each type of ticket was sold? That's what we want to solve. Okay, this is a how much times how many problem because we're trying to get this total value of 330. Now, let's see how this one's different from the one we just did. How much, and it's going to be how much money times how many what, how many tickets. It's got to make sense. You wouldn't say how much tickets. It doesn't make any sense. How much tickets? So how much money, how many tickets equals total value. Okay. We got student stud tickets and non-stud tickets. We know student tickets are $2, non-student tickets are $5. Now, we know we got 102 tickets sold all together. We can't put 102 here because that would mean 102 student tickets. So that brings up a problem. All right, here's the problem. Do we know anything about the number of student tickets or the number of non-student tickets? No, it just told us cumulatively there was 102 tickets. So we don't know anything about either one, so somebody's got to be X. It doesn't matter who's X. But now here's the deal. Let's pretend I have, how many tickets? 102. Let's pretend I have 102 tickets in my pocket, 102 tickets. And now I've used up X of them, so I've sold X of them. X of them are gone. How many tickets do I have left in my pocket? Well, I had 102, and X are gone, so I have 102 minus X. Does that make sense? I can check that in so many ways. Watch how I can check that. I can check that by adding this. This is supposed to add up to 102, and it does, because negative X plus X is 0, and I get 102. It's supposed to add up to 102, and it does. Think about this. If there was 2 tickets for non-students, then there would have had to been 100 for student tickets, because they have to add up to 102. So 102 minus 2 would be 100. So I can put in numbers to see that this is correct, or I could just see it adds up to 102. So that's what I know. So this is the total minus X, the total minus what you used up. I had 102 tickets, I used up X, so I have 102 minus X. And it doesn't matter even if you flip-flop these, it doesn't matter. Now, there's one column that's empty, squiggle. Use the formula. 2 times 102 minus X, and this is 5X. Now, I squiggle total value. That means that I have to write this equation about total value. Well, I know the total value is 330. So what does that tell me? That tells me that the total value that I got from the student tickets, whatever I made, this is what I made on the student tickets, this is what I made on the non-student tickets, together, that's the 330 I brought home. Okay? So here we go. Okay. So we got the student total value plus the non-student total value equals 330. Okay. So let's set this up with this color. 2 times 102 minus X plus non-student, which would be 5X, equals 330. Okay, which is 2 times 102, 204, minus 2X plus 5X equals 330. Combining before we move, I owe you 2X, I have 5X, so I have 3X, plus 204 equals 330. Subtract 204. 3X equals 126. No, that can't be right. What am I doing? Okay, hold on. Oh, that is right. 126. That's 204. 304. Oh, yeah, that is right. Sorry. 126 divided by 3. Divide by 3. X equals 42. What does 42 represent? 42 represents the number of non-student tickets. And what do you want to know? How many of each type? So there's 42 non-student tickets. But you also want to know how many student tickets. That's 102 minus X. 102 minus 42 is 60 student tickets. Is there a way to check this? Well, of course there are. Here's the check. 42 student tickets. Student tickets are $2. Sorry, this is non-student tickets. Non-student tickets are $5. That's $210. And 60 student tickets at $2. That's $120. And there's your $330. Okay? So again, total value. How much times how many is total value? And I think the key is in the chart. Okay, so whenever you have two unknowns and you have a formula, we're going to use the chart. And you're going to see that again in the next lesson. Okay, so let's take a look at this next question. All right, let's take a look at this one. A small plane carried 50-pound and 30-pound suitcases. There was a total of 40 suitcases weighing 1,640 pounds. How many of each type of suitcase was on board? Okay, now here's the deal. This is, again, a how much times how many. How much meaning how much weight for the pounds, because we want total poundage. Is that a word, poundage? Okay. All right, anyway, total pounds, and then we want how many of each suitcase. So this is what you know. Set up the chart. How much times how many equals total value. Try to set up the chart. We'll come back, click us back, and stop the video, try it, click us back, and we'll do this problem. Okay? All right, here we go. I didn't really know what to call these because they didn't really have a name, but how much weight, how many packages is what we're looking for. I don't care if you had that in there or not. I just wanted to show you what was going on. Well, how much weight? How many we have? Well, how much weight is a 50-pound package? 50 pounds. Okay, so this is 50. This is 30. Now it says a small plane carried 50-pound and 30-pound suitcases. There was a total of 40 suitcases. Okay, so there's a total of 40 suitcases. So that's how many, but there's not 40 of these, so I can't put 40 in here. There's not 40 of these, I can't put 40 in there. So somebody's going to have to be X, okay? Now, if there were a total of 40 packages altogether, and I've already used up X of them, how many did you put here? Well, that would have to be 40 minus X, right? I had 40 packages in my pocket. I used up X of them. 40 minus X. Again, I'm going to squiggle. Almost all of these can be squiggled in the last one. That's just a little hint. I mean, you could do these some other ways sometimes, but really it's kind of easy if you do that. Okay. Use the formula, 50x, 30 times the quantity, 40 minus x. And now I need to write the equation about total value. And we know the total value is 1,640 pounds. Because this is the pounds. This is how much all the 50-pound packages weigh. This is how much each of the 30-pound packages weigh. So I know the total value of the 50. Well, let me do it this way. Let me erase that so it doesn't look like that. Total value of the 50-pound packages plus the total value of the 30-pound packages equals 1,640. Okay, so let's set it up. That's 50x plus 30 times the quantity 40 minus x. You cannot put x minus 40. It's not the same thing. In x minus 40, the x is positive, the 40 is negative. It's different. Because if I have 3 packages, then 3 packages that are here, this would be 40 minus 3. This would be 37 that are here. If I use x minus 40, this would be 3 minus 40, which would give me a negative 37 packages. That makes no sense. So it's not the same thing. Okay, equals 1640. Here we go. 50x plus 30 times 40 is 1,200 minus 30x equals 1,640. I have $50, but I owe you 30, so I have 20. Now I got to solve this, so I'll subtract 1,200. 20x equals 440. Divide by 20. Divide by 20. X equals 22. What does 22 represent? 22 represents there's 22 50-pound packages. 22 50-pound packages. And now we want to check. We have 40 minus x. Or 18 30-pound packages. Okay? And of course you can check that. Just multiply. If I have 22 of these and 18 of these, I'm going to have a total of 1,640. Let's check it out. Okay, so 22 at 50 pounds is 1,100 pounds. And we have 18 at 30 pounds. is 540 pounds. That's 1640. Is that right? Yep, 1640. It's a go. So my answer is 22 50-pound packages and 18 30-pound packages, and that's it. Pretty cool, huh? Now think about that. How much times how many, okay? We can't just add it without knowing how much something's worth and how many you have. Let's see if this next problem is at all like this. All right, let's take a look at this problem. They want to know, does 30 milliliters of a 30% alcohol solution added to 50 milliliters of a 70% alcohol solution give you as much alcohol as 80 milliliters of a 55% alcohol solution? All right, here's the deal. This, to me, is really a how much times how many problem, but I really like the beakers, okay, because it's actually a fluid. But anyway, here's what I know. When I do add 30 and 50, I do get 80, so I'm happy about that, okay? That has to be true. This plus this has to be that, so that's okay. Here's what I know. When I take 70 milliliters and I put it to 70%, I'm sorry, a 70% alcohol solution, and I put it with a 30% alcohol solution, I'm obviously going to get less alcohol than 70% alcohol because this is going to dilute it. But is it going to dilute it to 55% based on these milliliters? So here's what I know. I know that if I have a 30% alcohol solution, 30% of 30 milliliters. That's what I have to do. Well, to make 30%, remember we have to change the percent to a decimal, so that's 0.30 times 30. 0.30 times 30 is 900, two places, so that's 9. So really we have 9 milliliters of alcohol. That's all we have of alcohol, 9 milliliters. Not much alcohol. If I add that to this, 70% times 50, which is 0.70 times 50, which is 3500, two places. I have more alcohol here, right? 35 milliliters of alcohol. I want to know if that's the same, and by the way, this is 44. I want to know if that's the same as this, 55% of 80. Okay, percent, sorry. So this is going to be 0.55 times 80, and that's going to be 8 times 5 is 40, 44, give you another 0, 44. This is going to be 44. It is the exact same, and the reason it's the same is that because this 30% of alcohol diluted this, and we had enough milliliters here to add to be the same thing here. So that's what we have to understand. This is truly a how much times how many problem. But this plus this has to equal this. Here the percent alcohols, they're going to dilute each other or when they mix, okay, if one's less than the other. So we're going to do some of these problems, and these are called mixture problems. So let's just summarize for 1 second, and this is not in your workbook, but we started a long time ago in, I don't even know, I think it was Mod 8 lesson, I don't know. We started with simple problem solving that was just an exact translation. Then we went to 2 unknowns. Then we went to 3 unknowns. Then we went to integer problem, consecutive integers, which was also, after we set up the key, a direct translation. Then we went to problems like this in this lesson, which was at first how much times how many equals total value. These are called mixture problems. But in a way, wasn't those other problems we just did a mixture problem? We were mixing the different kinds of tickets together, the different kinds of, what do we have, pounds of suitcases, the luggages. They're all kinds of mixture problems. Later on, we do a different problem in the next section called a motion problem. But I said earlier that they all fit in only 3 or 4 different categories, and that's what I'm talking about. They're either direct translations, or 2 variables, or 3, or a chart with a formula that is a mixture problem, and then later motion problems. So let's do another problem and make sure we understand it. Because we were just checking this. Let's do an actual problem now. All right, I've been waiting all day to do this one. Okay, we have Dr. Summer has a 5% alcohol solution and a 15% alcohol solution, and he wants to know how many liters of each that he has to add together to make 50 liters. So he wants to make 50 liters. So he's going to take some of this, right? I don't know how much yet. And some, because we're going to have to actually solve the problem. We're going to have to actually solve the problem. Some of this, and we have to make 50 liters, so it's going to have to add up to 50. Okay? So we have to know how much of each so that this is actually a 12% alcohol solution. So we're going to solve this in a minute. You thought I was done, didn't you? You thought I wasn't going to come back for this. Too bad. You wish it was poison. Okay, at any rate, we have 5% alcohol solution and a 15% alcohol solution, and this is what we want to get. So does this make sense to you? Look, I'm going to take this, add it to this, and get this. So obviously, whatever this number is, plus whatever this number is, has to be 50. Okay, those two numbers have to add up to 50 because that's what we want in the end. Okay, so here's the deal. This is exactly kind of, that really makes no sense. This is almost exactly what we did before, where we talked about how much times how many. I'm going to make sure the percentage is on the bottom just to be consistent, and I'm going to make sure how much we have is on top. Well, I know I have to add some of this alcohol and some of this, some of the red with some of the green to get this. However, I don't know how many of each, or either one in fact. Since I don't know how many of either one, I make somebody X. It doesn't matter which one I make X, but somebody's got to be X. I'm going to move this over. I want to write the word liters in there. So this is X liters. But remember the deal. The deal is that we have to get 50 liters. So if we have 50 liters, but I've used up X of it, so think of me having 50 liters in my pocket. I don't know how I would do that, but I have 50 liters in my pocket. Again, this is the same thing we did before, and I get rid of, or I use up X. Well, how many do I have left? Well, I have 50 minus the amount I used up. And again, this has to add up to 50, and it does. So this is the setup. Now, all we do is remember it's how much times how many. How much times how many. Actually, this would be how many, and this would really be how much, okay? Not that it matters much because it's commutative, but it's how much times how many. And this is really, again, how much, and that's really how many liters I have. Again, it doesn't really matter, but I'm multiplying. Another way to think about it is I have 5% of this, I have 15% of this, I have 12% of this, which means I'm multiplying. So either way you turn it, it's multiplication. So now I have 0.05, because that's 5%, of 50 minus X, plus, so we multiply what's in the beakers, 0.15 times X equals 0.12 times 50. Now you can work with the decimals, or you can clear the decimals, whatever makes you happy. I'm going to clear the decimals because that makes me happy. And I can move it 2 places. Well, if I move it 2 places, it means I'm going to multiply by 100. Remember, this is one term because there's no plus or minus between here. Think of what's in the parentheses as one thing. Okay? I'm multiplying by 100. I'm multiplying by 100. And now there's 3 factors here. So there's 3 factors here, there's 3 factors here, and there's 3 factors here, this one being a big factor. So you multiply any 2 together, and of course I'm going to multiply these 2, because when I do that, it clears the decimal. That's why I'm doing this. So we get 5. We don't touch what's inside the parentheses until after we distribute. Plus, same thing here. Plus, same thing here. 100 times 0.12 is 12 times 50, which gives us 5 times 50 is 250 minus 5x plus 15x equals 12 times 50, or 600. Combining like terms, we have 250 plus 10x equals 600, okay? So notice what I did up to here, okay? Take a second to copy that because I'm going to erase this and I'm going to continue this. I'm just going to erase this right here. I want to keep this. Erase this so I can continue that problem. Okay, this is where I was. So I'm going to subtract 250. Now look, I get to divide by 10 in a minute. That's easy. That makes my day. 10x equals 350. Okay, divide by 10. Divide by 10. X equals 35. What is 35? 35 liters of the 15% alcohol solution. 35 liters of the 15% alcohol solution. That's part of the answer. The other part is, for the 5%, it's 50 minus X, which is 50 minus 35, or 15 liters of the 5% alcohol solution. So that's my answer. 15 liters of the 5% and 35 liters of the 15%. And if you think about it, I can check that by multiplying. What was this one? 5% was 15. 15 times this, and 35 times this. And notice 15 plus 35, yes, 50. And that's how you solve that problem. Pretty cool. And I didn't even die. Awesome. All right. How much water must be added to a radiator that contains 10 gallons of an 80% antifreeze solution? Okay, to dilute it to a 50% antifreeze solution. That should make sense. I add water, so there's no antifreeze in water. I add water to 80% antifreeze, I dilute it. Okay, so we have to figure out how much antifreeze we need. So here's what I'm doing. How much water, so I'm going to make this beaker be water. Beautiful, huh? You're welcome. How much water must be added to a radiator? This is the radiator. Oh, it looks the same as the beaker. What are you going to do? Okay, so added to the radiator that contains 10 gallons of an 80% antifreeze solution, okay, to get, right, antifreeze, to dilute it to this, a 50% antifreeze solution. Okay, here we go. Let me just write the same thing there, because that's important. I wrote anti-F here, I'm going to write anti-F here, which is antifreeze, right? And I'm going to tell you why I'm doing that. I'm making a big deal about that. Okay. Okay, and we want, does it say how much? It doesn't say how much. Okay, so how much water? I have no idea, that's why this is X. So X gallons, that's what I have there. Now here's the point. If this is antifreeze and this is antifreeze, this has got to be percent antifreeze. So we have to decide, and we have to know, they didn't tell us, but we have to know how much antifreeze is in water. I hope it's 0, because if not, I think we'd all be dying. Okay, so this is 0, because 0% antifreeze is in water. That's where I got that 0. If it said pure antifreeze, it would be 100% antifreeze, but it says water. There's no antifreeze in water. Okay, now, here we have all the bottoms. We now need all the tops. Remember from that other thing that I did earlier with that red and green stuff? I'm taking the X and I'm adding it to the 10. If I take X and I add it to 10, what do I have? Not 10X, because 10X means I'm multiplying. X plus 10 is X plus 10. It's so easy, it's hard. I have X gallons, I add it to 10 gallons, I have X plus 10 gallons. Make sense? Okay, here we go. Now I just multiply. This is 0X plus 80% times 10 equals 50% times X plus 10. That's all you do. You multiply what's in a beaker. It's just like how much times how many, right? This of this. So that's it. Okay, now I don't need this because this is 0. If you want to clear the fraction, I do. I like clearing. Sorry. If you don't, I mean, sorry, clear the decimal. I like clearing. If you don't, well, then don't clear it. Okay? And we got 100 times 0.80, or 80 times 10 equals 50 times the quantity X plus 10, which is 800 equals 50X plus 500. Subtract 500. We have 300 equals 50X. Almost done. Almost home with this problem. Divide by 50. X equals 6. What does 6 represent? 6 represents gallons. The question is how much water? I need 6 gallons of water to dilute it to get this much antifreeze. And how much antifreeze would this be? 16 gallons. How do I know this? Because this is 6. And 6 plus 10 is 16. But they didn't ask me that. They just asked me how much water I need. And this is how much water I need. That's it. That problem's done. Awesome. Okay, I hear you guys making fun of the way I say radiator. You think it's radiator. Well, say it the way you want. At any rate, okay, the next problem is about a salt solution, okay? And what I need you to do is just go back to your workbook and set this one up. Do not solve it, just set it up in the beakers, okay? This way we know that you know how, I know, somebody knows that you know how to set it up. If you're having some trouble, call the instructor over. And then click on and we'll get started. All right, how'd you do? Let's take a look. How much each of a 2.4 percent salt solution. Okay, so you have a 2.4% salt solution. Must be mixed together, so you're adding it together with a 4.6% salt solution. In order to produce, that means it's going to equal a 3% salt solution. Somewhere it's got to tell me something else. Oh, 90 liters of a 3%. 90 liters of a 3% salt solution. Remember, we need everything in these beakers, the amount and how much, okay, how many and how much, and we're going to multiply them. Well, again, we don't know about either one, so it doesn't matter which one we call x. We can call this one x or that one x. It does not matter. But now if we have 90 liters, but we used up x of it, yes, this is 90 minus x. So now we can solve the problem. 2.4% is 0.024 times 90 minus x plus 0.046 times x equals 0.03 times 90. All right, let's talk about what we might want to do with this. I want to clear, and I'm going to clear because I got the chalk or the marker. All right, so here we'd have to move it 3 places. Here we'd have to move it 3 places to clear the decimals, but here only 2. You can't move it different amount of places, or it won't keep the equation in balance. So we have to move it the maximum number of places, which is 3. So we have to decide what we're going to multiply by. We know it's a power of 10 that will move it 3 places. Well, 1,000 has 3 zeros in it, so that's the number we need to use. So we're going to multiply that by 1,000, this by 1,000, every term, this by 1,000. It's okay. It's okay. I know, don't freak out. I know it only needed 2. It's all right. It doesn't matter. As long as we keep it in balance, move it 3 places, and this is going to give us 24 times 90 minus x plus 3 places. That's going to give us 46x equals 3 places. That's going to give us 30. That was painless. Painless. Okay, here we go. 24 times 90. We're going to have to distribute. 24 times 90, that's 6, carry the 3, 18, 2160, 2,160 minus 24x plus 46x equals 2,700. Okay, still with me here? Let's see. Let's look at this. I owe 24, but I have 26, so I have 22x. Okay, plus 2,160 equals 2,700. Subtract 2,160, or 2,160. Now we're getting pretty low here. 22x equals 0. We're going to have to borrow. We got 4, we got 5. So we have 22x equals 540. I can come here. 22x equals 540. Ready? We're going to divide by 22. We're going to divide by 22. Wow. Okay, this is going to be a little ugly. Let's do this. Let's reduce this. If we reduce this fraction, this is going to be, I'm going to divide by 2 here, I'm going to divide by 2 here. And that's 11. Anytime you divide by 11, it's pretty ugly. Okay, so this is 270 divided by 11, which is approximately, let's change it to, because if I say 270 divided by 11 liters, what is that to you? I'm going to change that to a mixed number to make this kind of easy. Okay, so 11 into 227 is twice with 5 left over. That's 4, which is 44, 6/11. So it's 24 and 6/11 liters. That is your answer for, I don't know which one, hold on. How much each? Okay, so that's your answer for the 4.6% salt solution. Okay, 24 and 6/11 of the 4.6% salt solution. Oh, salt, salt. Oh, it's like salt squared. Sorry. Okay. Now, that's part of your answer. Now we have to get the 90 minus x. Oh, this is going to be too much fun. 90 minus x, that's for the 2.4%. X is 24 and 6/11. Oh, we're bringing it back. Bringing it back. We're going to have to borrow 1. This is 89 plus 1. We're going to make the 1 look like 11 elevenths. Remember how to do this? This is 89 and 11 elevenths minus 24 and 6 elevenths, which is 5 elevenths. And this is 65 and 5 elevenths of the 2.4% salt solution. And that's it. You're done. So 65 and 5 elevenths liters of the 2.4% solution, salt solution, and 24 and 6 elevenths of the 4.6%. And these are liters. 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 Oh, that says liters. Okay, and we're done. That was a tough problem because we had an ugly, ugly answer. And that, I think we might have one more problem, or is that it? Oh, one more problem that I think comes out a little nicer than that. Okay, so let's take a look at this next problem. Okay, we're going to Wawa. Wawa is actually a store in Long Island. Okay, go ahead, laugh. Ha-ha. Okay, now, what I'd like you to do is go to your workbook, stop the video, and set this up. Now, instead of beakers, I use, because we're talking coffee, you wouldn't put coffee in a beaker, you would put it in a bag. So here's my bag. Okay, there's my bag. So instead of a beaker, we use a bag. So set this up, just like you would with the beakers, make it a bag. If you'd like to make it a beaker, make it a beaker. I really don't care, but that's my bag. All right, and then we'll click back, and we'll do this problem. Okay, Wawa has coffee that sells for $7 a pound. $7 a pound, okay. And coffee that sells for $4 a pound. How many pounds of each are needed to get 21 pounds of coffee worth $5 a pound? So you're going to mix these coffees together. I'm so creative with my bags, aren't I? Okay, and we want to get 21 pounds. Oops, 21 doesn't go there. That's the money. 21 pounds of coffee that is worth $5 a pound. $5 a pound. Okay. Well, I don't know how much of this or this, so one of them is going to be X. Doesn't matter which one is X. And then this one is total minus what I used up, or 21 minus X. Again and again and again. So now I multiply how much times how many? Exactly what's in these beakers. I multiply. Okay, so it's 7X plus 4 times 21 minus X equals 5 times 21. 7X plus 84 minus 4X equals 105. Okay? 7X minus 4X is 3X plus 84 equals 105. Almost done. Coming to the finish line. 3X equals, that's 1, borrow 21, divide by 3, divide by 3, X equals 7. 7 what? 7 pounds. We want 7 pounds of coffee. How many pounds of each? We want 7 pounds of coffee at $7 a pound. 7 pounds at $7 a pound. We want 21 minus X, 21 minus 7, or 14 pounds of coffee at how much? $4 a pound. And of course you want more at $4 a pound because it's going to bring the price down to 5, because 5 is closer to 4. Now, I have a question because I really haven't addressed this and I wanted to. Here's my question really quick. Had you made this X, what would X have come out to be? Remember, X is the $4 a pound. X would have came out to be 14. And then this one would have been 21 minus 14, which would have been 7. So you would have got the same answers, okay, in the end. They would have represented the same things. And that is the end of Mod 8, the biggest mod in here. All right, next, Mod 9.